Hey everyone, welcome to another video. I'm Umang Mawani and I solve coding interview question. Today we will start with our BFS playlist and the first problem is of medium category binary tree level order traversal. The description says given the root of binary tree, return the level order traversal of its nodes value that is from left to right and level by level. For example, if this is a given tree, we can see that in the output we have written 3, that is the root element, then 9 and 20, its left and right node value, and then 15 and 7, the left and right value of 20. So since we need to traverse all these nodes in each level before we move into the next level, we have to use BFS technique to solve this problem. Let us go through one example and understand how we can use BFS. Now you can see over here we will be using queue to efficiently traverse in the BFS fashion. So we will start by pushing the root node into our queue, and also we will keep iterating the queue until it is empty. In each iteration, we will first count all the elements that are present in the queue and we will name it as level size. So that will indicate that we have these many nodes in our current level. For example, here the queue size is 1, so the level size is 1, indicating that there is one element in that particular level. Now next, we remove the level size nodes from the queue and push their value in an array to represent the current level. So from here we have removed 12 and we have put it in our output array indicating the first level. Also, we will insert its left and right node into our queue. So 7 and 1 will be placed in the queue and 12 will be removed from the queue and placed into our output array. Now since queue has two elements, the level size will be 2 and it indicates that there are two elements in the next level. So again from the queue we will remove 7 and 1, we will place in our output as level 2, and also we will place the left and right nodes into our queue. So we will add 9, 10 and 5. Now again since the queue size is 3, level size is 3, and we will remove it and place it as level 3 output. Now since 9, 10 and 5 does not have any left and right node, our queue will be finally empty, which will be the terminating condition, and we will return our output indicating 12 in the first level, 7 and 1 in the second level, 9, 10 and 5 in the third level. Now while we code, we will try to follow the exact pattern that we just saw in this example. So let us understand that. First, I will initialize my result, that will be our return type, that is list of integer is equal to new array list. Then we will check for the condition. If the given root is null, we will simply return result. Next, we will initialize queue of type tree node equal to new linked list, and we will add root as our first element of the queue. Now next we will write our while loop which will run until the queue is not empty. So while queue is not empty, we will write the size of the queue in the level size variable. We will also initialize the current level list inside the while loop, because as you saw, the value which we remove from the queue are being stored in the list format for each level. So current level will help us to store those numbers. Now next we will write a for loop to traverse our queue starting from I equals to 0 up to the level size. Now in this for loop, we will pull our first number from the queue and we will name it as current node, and we will add the current node value into the current level that we declared over here. Now after adding its value, we will check if the current node has any left node. If yes, we will add it into the queue by queue dot offer, and similarly if current node dot right is not null, then we will add that node into our queue. Now once this for loop is completed, that means we have completed the traversing of that particular level. So now whatever value our current level list holds, we can add it into our result. So we'll write result.add the list of current level, And once the while loop is completed, that means once the queue is empty, we have finished traversing all the nodes of a given tree, and in the end we can simply return result. So now let us run the code, and it is accepted. Now before we submit, the time complexity of this above algorithm is O of n, where n is the total number of nodes in the tree, and this is due to the fact that we traverse each node once. Also, the space complexity of the above algorithm is O of n because of the queue. So now let us submit the code, and it's a success. So guys, I hope you understood the BFS approach and how we can use it in this problem. If you have any queries, do let me know in the comment section and I'll be happy to answer. Also, like, share and subscribe this channel to help me solve more problems for you. Thank you.